Today I would like to deliver this lecture on version control and Git and GitHub. Okay. So first of all, what is a version control system? Okay. A version control system, or VCS, is a system that allows you to manage multiple revisions of the same unit of information. Okay. For example, let's say documents or let's say sources of files or any other item of that sort. Okay. And as the graphical depiction shows, a VCS allows multiple people. For example, here we have four to cooperate and share files. Now, let's drill into this concept in a little more detail, okay? And let's do that by discussing why a VCS useful, especially in the context of software, in the context of software engineering and web development and so on. Okay, first of all, using a version control system enforces discipline because it manages process by which the control of items passes from one person to another. Another important aspect of VCS is that, well, it allows you for archiving versions. So you can store subsequent versions of source controlled items into a VCS. Okay. But not only you can store versions, but you can also maintain a lot of interesting and important historical information about these versions. Okay. For example, a VCS will store information such as like who is the author for the specific version stored in the system, or let's say on what day and what time that version was stored, and a lot of other interesting information about the specific version of the item. Information that you can retrieve and, for example, use to compare versions. Obviously, the fact of having a central repository in which all these items are stored enables collaboration. So people can more easily share data, share files, share documents through the use of VCS. And I'm sure that you all had the experience of deleting a file by mistake, or let's say modifying a file in the wrong way, or in the most common cases of changing something in your code, for instance. Okay, breaking something and not being able to go back to a version that was working. So that was a common problem, right? So not remembering, for example, what is that you changed that broke the code. Okay. In all these cases, a version control system can be extremely useful because it will allow you to recover from these accidental deletions or edits. For example, to go back of yesterday's version that was working perfectly, and also to compare, for example, yesterday's version with today's version and see what is that you change. Okay. And finally, a version control system will normally also allow you to conserve and save disk space. I mean, on both the source control client and on the server. Okay, why? Well, for instance, because it's centralizing the management of the version. Okay? So instead of having many copies spread around, you will have only one central point where these copies are stored, or a few points where these copies are stored. Okay. In addition, version control system often uses efficient algorithms to store these changes. Okay, and therefore you can keep many versions without taking up too much space. So as you can see, version control, just a quick recap, version control, or some people call it revision control or source control, is all about managing multiple versions of documents, programs, websites, and so on. Okay, and some well-known version controls of VCS, sorry, I had a mistake here, of VCS is CVS, Subversion, then we have Mercurial, and finally Git. Okay, and Mercurial and Git treat all repositories as equal. Okay, so we're going to talk about mostly Git. And distributed systems like Mercurial and Git are newer and gradually replacing centralized systems like CVS and Subversion. Why do we need why do you need a version control system? Well, for of course for working by yourself. Okay, so if you're doing it if you're doing a project on your own, it gives you a time machine for going back to earlier versions. Okay, it also gives you a great support for different versions, for example standalone web applications and so on, of the same basic project. If you're working with other people, it greatly simplifies concurrent work, and for example merging changes, and also a check who made which change, so you can blame someone or praise someone. And also it also can help you to get an internship or job, because any company with a clue uses some kind of version control, and companies without a clue are bad places to work. And also you can actually highlight or showcase your projects by sharing your repositories or by sharing your, let's say, GitHub account. How VCS works. So these are the essential actions. So this is what I want to do next, is to look at how version control system actually work. Okay, we saw what they are. Okay, and we saw that why they are very useful, but how do they actually work? And we are going to do that by starting from some essential actions that version control systems perform. Okay, and the first one is the addition of files. So when you use a version control system, you can add a file to the repository, and at that point the file will be accessible to other people who have access to the repository. Now the fundamental action is also commit. Okay, when you change a file that is already in the repository, let's say, when you make some local changes to a file that is already in the repository, so you want then to commit your changes to the central repository. Okay, so there is essential information you need to understand, is that in GitHub, in Mercurial and Git, you have what we call centralized repository, and we have also local repositories. Okay, so and we will talk about this one a little bit later, so I will explain it with some examples. And finally, another fundamental action is the action of updating a file. Okay, if let's say we have a repository and someone else modifies it, modifies some files in the repository, so what I can do, I will be, well, as a part of this repository, as a member of this repository, I will be able to get the changes that other people made to that files. And these are just three of the basic actions, but there are many more. Okay, and we will see several of those. Okay, and before looking at the additional actions, I would like to see what is the basic workflow in version control system using the three actions that we just saw. Okay. And to do that, I'm going to use two of our friends, let's say Brad and let's say Janet. Okay, so we have Janet here and Brad on the right hand side, and we have also VCS that they are using. Okay, now imagine that Janet creates a file, let's say called foo.txt, and puts some information in the file. And at that point, she might want to add the file to the repository, and to commit is so that her changes and the file get to the central repository. Okay, and when she adds and commits, that's exactly what will happen in foo. It will become available here in the central repository. And will be accessible to other users. Okay, in this case, it will be accessible to Brad. Okay, if Brad wants to run an update command, what will happen is that the file foo.txt will be copied on the local workspace of Brad, and Brad will be able to access the file. Okay, And at this point, Brad might want to modify the file. For example, add something to the existing file, add some text, okay? And after doing that, he may also want to share the updated files with Janet, okay? So to do that, he will commit the file, and the result will be exactly the same of when Janet committed her file, okay? So that updated file will be sent to the repository, to the central repository, and the central repository will store that information and make it available for others. Okay, so now Janet, if Janet performs an update, she will get the new version of food.txt with the additional information that was added by Brett. And we will see all of this in action in our demo that I'm going to show in a couple of minutes. Okay. So something else I want to mention as well is that there are many different version control systems. Okay, but we can classify them normally in two main types: centralized and decentralized distributed VCS. Okay. So what's the difference between these two? Let's use again our friends Janet and Brett. And in this case of a centralized version control system, there is a single centralized, as the name says, repository on which they are committing their files. Okay. So when Janet commits a file, the file will go from her local repository to the central one, to the central working repository, and the same will happen to Brad. Okay, and the decentralized distributed VCS is a little more interesting because in this case they will both have sort of kind of a local repository in which they can commit their changes. So they commit changes without the other users of VCS being able to see these changes. Okay, so in our case, Janet can commit her changes to her local repository, and Brad can commit changes to his local repository. Okay, and when they are happy with the versions, so when they are happy with the final version of their files, they already kind of release the new version. They can push it to a central repository, and at that point it will become available to the others, and so to the other, I mean, users of VCS. Okay. And there are several advantages in any decentralized or distributed system, and I'm just going to mention a few because there are really many of them. Okay, and one is the fact of having this local repository. Okay, and if you used VCS before, for example GitHub, I'm sure that you've been in a situation in which you want to kind of take a snapshot of what you have, but you don't want that snapshot to be available to the other users, okay? Because it's still not ready to be released, to be looked up. So if you are using a centralized system like this one, there really no way you can do it unless you make a local copy, okay? Which is something we said you don't want to do. With a decentralized or distributed system, you can commit your local changes here and here, for example, and you can push them to the central repository only when you're ready. So first you commit it to the local one, and only then you can push it to the central one. And another big advantage is that you can use multiple remote repositories. Okay. In fact, centralized is not the right name for this one, the first one. This is just a remote repository, and I can have more than one, exactly. Okay. For example, Bright may want to push to another remote repository, and for instance, this could be a repository where the files are accessible for wider distributions. So imagine developing a web application in which a team is sharing internal versions, and then only some of these versions are actually pushed to the repository that is seeable to the whole world. And one good representative of distributed version control systems is Git. okay, and a distributed version control system that was initially designed and developed by Linus Torvalds. Okay, so I don't know whether you know this guy, but Linus Torvalds is so he's the basically the guy who started and created the Linux operating system. Okay, and Linus was unhappy with the existing version control systems and basically wanted a different one. He wanted to use it for maintaining the Linux kernel, and in particular he wanted one with some key characteristics. For example, the fact that it was distributed. He wanted it to be fast, and also he wanted to be to have like a simple design, and he wanted to have a strong support for parallel branches, because many people were contributing to the kernel at the same time, and therefore there are many different branches of development, for example in web development as well. And finally, he wanted to for the version control system to be able to handle, you know, very large projects. And as the Linux kernel is, and as the Linux kernel is like a big operating system, and he wanted to do it in a very efficient way. So if you want to get an idea of how popular Git is today, there was a survey performed across the web developers and some software engineers, and it showed that in 2013 Git was used by about 40% of the developers. Okay, and of course for this course for web technologies we will use Git and GitHub. Okay, so before we jump into the demo, okay, I would like to give a high-level overview of the Git workflow, which will help you better understand it. And let's do the following. Okay, let me explain. So let me start by representing four fundamental elements in the Git workflow, which are these four. So the workspace, which is the local repository, the index, or also sometimes called the stage, and we will see in a minute what the index is. Then we have the local repository. We also refer to this as head. In the when we will explain the different commands. Sorry, and sometimes it's also called flow. And finally, the remote repository. If you consider a file in your workspace, it can be in three possible states. It can be committed, which means that the latest changes to the file are safely stored here, okay, in the stage. It could be modified, which is the case of file being changed and none of these changes being saved to the local repository. Okay, so locally modified, and they can't be changed. Okay. And stage means that the file is basically a part of a certain index, and what that means, that is being tagged to be considered in the next commit. Okay. And I know this is not all 100% intuitive, so let's look at this again by considering the actual workflow, and let's see what happens when you issue the different commands in Git. Okay. So the first commit that you normally run in case if you're getting access to a remote repository is the git clone command, and the git clone followed by the URL for that repository will create a local copy of the repository in your workspace, in your working directory. Okay, and of course you don't have to do this step if you're creating the repository yourself. Okay, oops. The next command that we already saw is the command add. What the command add does is to basically it adds a file that is in the workspace to the index. Okay, so we are going from workspace to the index stage. And we saw that after that the file is staged, so it's kind of marked to be committed but not yet committed. Okay. And here I'm just mentioning this -u option. Okay, If you specify the -u option, you will also consider deleted files. But let's not get there for now. Okay, we'll talk about then when I'm going to do a demo. Okay, and as I said, if you add the file, it just gets added to this index. Okay, but it's not actually committed. So what you need to do next is to commit the file. So when you execute git commit, all the files that are stage that kind of released here, their changes will be committed to the local repository. And so your files, as I was saying, they can be in 3 states. They can be in the working space, in the index, and the local repository. They will go from the modified state to the stage to the stage state, where when you execute the add command, and then from the stage state, they can be committed to the local repository by using the command git commit. Okay, so at this point, your changes are safely stored in the local repository. Notice that you can perform these 2 steps at once by executing a commit/a. So if you had a set of modified files and all these files are already part of the repository, so they are already known to your control system. Okay, so you can simply execute a commit-a command. Okay, and as we discussed when we look at the difference between a centralized and decentralized version control system, we saw that in the case of the decentralized, there is a local repository, which is this one. And then you have, after you saved your changes to the local repository, you can actually do the following. Okay, when we saw in the case of what we saw in the case of decentralized, there is a local repository, which is of course this one. Then what you have to do, you explicitly push your changes to a remote repository. Okay, and this is exactly what git push command does. Okay, it pushes your changes that are in the local repository to the remote repository. So at this point, all of your changes will be visible to anyone who has access to that remote repository. Now let's see the opposite flow. So how it works when you're actually getting files from the repository instead of committing files from the beginning. Okay, the first command I want to mention is git fetch command. And what git fetch does is actually gets files from the remote repository to your local repository, but it's not yet in your working directory. Okay, and we will see why this is useful. Okay, why we have to do this operation and having files in the local repository but not in your workspace. Okay, so what that means is just you have to make sure that we are on the same page. Okay, is that you will not see these files when you're doing it on your workspace. Okay, you will still have your locals files here. So this is a sort of like physical distinction between workspace and your local repository. And in order to get your data from the local repository to your workspace, you have to issue another command, which is command git merge. And git merge will take the changes in the local repository and get them to your local workspace. And at this point, your files will be updated to what was fetched from the remote repository. And so now you actually kind of synchronize your working directory, your workspace is kind of synchronized with the remote repository. And there is a shortcut command called git pull. In case if you want to get the changes directly to your workspace from the remote repository, okay, you can do it in a single command git pull. You can issue a git pull command And what will happen is that the changes will get collected from the remote repository, and they will go to your local workspace at once. Okay, and they will be also stored in the local repository on the way. Don't worry about this one. This has the same effects as performing a git fetch and git merge commands together, and we can do everything at once, as I said. So the last thing is why we want to fetch and merge as two separate operations, as I said. Okay. So one of the reasons is because this allows us to compare files before we actually get the latest versions of the files. Okay. In particular, we can run command git diff to get the difference between my local files and the files in my working directory. And what I can do, I can fetch the files from the remote repository. I can fetch the files from the remote repository, and I can run a git diff command and check what the difference are. Okay, and based on the difference, decides whether I want to merge or not. Okay, whether I want to merge a remote repository with a workspace. Okay. So yeah, basically that's it, all about Git and Git workflow. And let us begin now. So let us have a very quick demonstration on some of the Git commands. And yeah, so let us do the following. So I'm going to stop here. And the first thing is I showed you last time, but you actually have to create an account on GitHub. Okay, so in order for you to create an account on GitHub, you can go to github.com, sign up here, and then after you sign up, you will be able to sign in with your username or email address and your password, of course. And this is how your homepage is going to look like. Okay, so this is what we have. We have a remote. We can create here remote repositories. So this is GitHub, and GitHub once again is a decentralized VCS. Okay, so let us go back to Git. In order for you to install Git, you can go to git-scm.com. And if you open this website, you have downloads here. You can download it for Mac, you can download it for Linux and for Windows. And I already have it installed on my computer. Okay, so once you install Git, this is what you will get. This small terminal called Git Bash. And this terminal actually allows you to run the Git commands. Okay. And we will do one of the commands, or I will show you some of the basic commands here, and also some of the basic Linux commands as well. So the first Linux command that is common for Mac operating systems, that is common for Linux operating system, and that is common for Git Bash here. And this is the command ls. It actually lists all the directories and files in the current working directory. So I'm currently on my C disk users, and this is my username. So to check your current directory, you can also run command pwd. It will show you like this. So this is my current directory I'm in. So from this place with ls commands, it actually tells me where I can go next. So to what directory I can go next, or probably what files I can find in this directory. But there are no files currently I'm interested in this repository, but there is another one called desktop. So basically this is my desktop directory, and this is where I can this is where I would like to go. Okay, so I can say cd, and cd allows us to move to the next or to the previous repository. Okay, and I can say, or repository, or people call it directory, sorry, cd desktop. Okay, and the syntax is also very important. So if it's written with uppercase, I think you need to write it the following, also with the uppercase, with capitalized letter. Or if you have, let's say, if your directory consists of two words, probably you need to write them in quotation marks. Okay. but not for desktop. So we're just going to say cd desktop. Okay, and if I run pwd once again, I am on my desktop currently, and if I run ls commands, well, I can see I have file or folder apps, I have Visual Studio Code here, and I have TS201, 2001, sorry, on my desktop as well. So those are the basic Linux commands that you will need. We also know touch, that allows us to create files. So for example, touch text.txt will create a text file, an empty text file. We also can create folders or create directories. We can say mkdir, and it allows us to create a file or directory, sorry. We can say it hello world, for example, and it will create directory hello world. And other commands are, for example, rmdir will remove it, hello world. We now removed our newly made directory, and just rm will allow you to remove files. rm.txt will delete this one. So those are the basic commands. Okay, once again, ls, pwd, cd. Okay, and in order for you to go back to the previous repository, so currently if I run it, I am on my user's name. Okay, so if I run ls commands, I am on my desktop currently. So what I can do, sorry, not on my desktop, I'm currently in my user directory. So I can go to desktop, okay, and I can go from this place to, let's say, apps. Okay, so currently I am inside of my apps, and those are the apps that I have. For me to go back, for example, to desktop, I need to run a command cd ... and it will bring me back to my desktop. Okay, and if you want to go back once again, you can say cd ... and it will bring you back to your initial place. So those are the basic Linux commands that I showed you. Okay, and let's move to the commands that we are going to use for Git. Okay? And let's do it for two cases. So the first case is, once again, let me show you. So the first case that we're going to have is when we create a remote repository first, and then, so this is, sorry, we will have this case first. So we will have a remote repository first, and then we will get changes from the remote repository. So in order for us to create a remote repository, we go to our github.com, okay, and here we create a new repository. Okay, and for us to create a new repository, we need to provide a repository name. So let's I will call it ideal pancake. Description is also optional. We also can make it public or private, but I will keep it public. And the last thing is I would like to initialize it with a README file. Okay, so this is README file actually helps me to provide information on my repository later. And if you click create repository, okay, your remote repository, this one, is has been created. Okay, so now this is our remote repository. So, but we don't have our local repository, our stages, and our our workspace are not yet. Okay, so the next thing, the next logical thing is to pull it. So we need to use command git pull to get the changes from the remote repository to our workspace. And for that, I'm going to first open this code button, and there will be HTTPS, SSH, and GitHub CLI links, but I'm mostly going to use HTTPS, so I'm just going to copy this one. And in my terminal, I will do the following. First of all, I will go to my desktop because I would like to see changes on my desktop. Okay, and the next thing is I will run the following command: git pull, and I will paste that link that I copied. If I click enter, it says not a git repository or any other parent directories git. Okay, so something is wrong. Probably we need to do Git pull. Sorry. Interesting. Okay. Let us check this error. This is the first time I'm getting this error. Okay. What does fatal not Git repository mean? It means you attempted to run a Git command but weren't inside the Git repository. Make sure you've made it. Oh, sorry. Yeah, because we don't have the actual workspace, we need to first clone it. We need to run git clone command. So the git clone command wasn't presented here. So I'm just going to run a git clone command, and I'm going to say, I'm going to paste, oops, not this one. I'm going to paste this link. Okay. So what it does, it actually clones ideal pancake. So it clones the remote repository onto my desktop. So if I check it now, I have apps, I have desktop in it, I have TS2001, and I have my remote repository called Ideal Pancake. So it's no longer remote one, it's in my workspace. Okay. So if I get inside of it, so if I say cd ideal pancake, well, I'm currently in my workspace, in my working directory. So if I run git here, it will work first of all, and it will show me some of the basic commands here. So the next command that we can do is we will move to that stage, okay, to the second one. So we are going to make changes here. So our working directory is now not initialized with anything with anything but readme file. So what I'm going to do is I'm going to create files, index.html, and let's say style.css. And now I have, okay, now if I run ls command, I have now index.html file and style.css. So this is currently in my workspace. So the next thing I have to do is I have to stage it. So I have to run a command git add, and it will add all these files to the stage, to the index. So I will say git add, or let me even show you another command, git status. It's a very useful command. It says your branch is up to date with the origin main, so it's up to date with the remote repository, but we have untracked files. So untracked files means they are not in the local repository. Okay, so there are changes that you have in the workspace, but that are not committed to the local repository. Okay, so git status basically shows the difference between your workspace and your local repository. And for us, we need to first stage it. So we need to run git add, and you can add files one by one. So you can say git add index.html, and then you can run git add style.css, and you now added two files to this index. Okay, so you staged them, and if you run git status one more time, it says now it first changed the color, so it's no red anymore, it's green. So it says changes to be committed. So now you are in the stage, or in the index part. Okay. The next logical thing, you have to commit those changes to the local repository. So you need to run git commit. And well, if you would like to deliver some message to your team, you can run git m git commit, sorry, -m. So it will leave a message to that. So yeah, basically giving a name to that commit. So we can say this is our first commit. And if we run it, okay, it says 2 files change, 0 insertions, 0 deletions. Okay, so if we run our git status once again, so you can say your branch is ahead of origin main by 1 commit. Okay, so currently our local repository is 1 step ahead of our remote repository. Okay, so now we have made changes, but it's not available for anyone else but us. So what we can do, we can push those changes to the remote repository so that everyone can see it. So we can say git push and simply origin main, or just simply git push. Okay, and we will talk about branches a little bit later. Okay, or you can study branches on your own. Okay, it's a also very useful topic in Git. And if you say git push, well, it asks for credentials. Okay, so the first thing you have to provide is username for github.com, and in my case, I'm going to write it. This is my username, Salkenov1. So the next one, it will ask for password, but if we run our GitHub password, for example, I'm going to write my own password. Okay, it will say fatal error. It says support for password authentication was removed on August 13. Okay, so it was removed 1 month ago. So what we have to do is actually we have to fix it. Okay, so if we go to our GitHub account, okay, and if we go to settings here, so this is my remote repository once again. If I go to if I go to my account settings here, and if I scroll down to developer settings, and we can create what we call a personal access tokens. Okay, so now in order for us to access our repositories or our accounts, we need to create a personal access token. Okay, and you can see I've created one for web technologies already, but let us generate a new token together. So I can click generate new token. I can provide this name for, so let's say web development. Expiration date, let's put it 90 days. I think we can finish everything in 3 months. And select the scopes, and let's select all of them if you wish. Okay. Or let's say until the admin ends. Okay, that's it. So we now can click generate token. And now the personal token being generated by GitHub, and we can copy it. So we can click this button. So now it's copied. So the next thing for Windows users is to go to control panel, and here you can look for credentials. So credential manager, click here, you open it, you can click web credentials or Windows credentials, up to you. I open Windows credentials, and here you can if you don't have github.com, so you basically can create one. So you can say add generic credential. In the passwords field, you can paste your personal token. So this one you pasting to the password. The internet or network address, so we need to write the following. Okay, so support for password authentication was removed. Okay, so actually this website explains a lot about how we can fix this problem, but basically we need to create a network address git https //github.com, and username is the one that you have. For example, in my case is this one, and then you click OK. In my case, I already have one, so I'm not going to create another one. That's it. So you can close this one, and later on, okay, so when you will try to push your changes once again, so you will say git push, and if you click enter, It will ask now once again for your username. You can say your username, you can write it here, but instead of writing your password any longer, you don't need to write your actual password. Instead, you can paste that personal token of yours. So you can copy this one and you can paste it here, and if you click OK, this is what happened. Enumerating objects for done, and at the end to https github.com, your username idealpancake.git. Okay, and it says main to main. So but basically what happened is that if you go to your repository, where's my ideal pancake? So this is my remote repository, and now it is initialized with index.html and style.css. And this is the message that I wrote in my commit message. So as you remember, I said this is our first commit, and this is what actually have been tracked by github.com. Okay, and it was added 5 minutes ago. Okay, so yeah, basically these are the changes that I've made to my remote repository. So now everyone from the team can get those files, they can get those changes. And GitHub allows you to also track the changes. So you can say, if you click this one, you can see who has committed to this repository. And because I was working on my own, so those are the two commits that I've done. So initial commit, and this is our first commit. But let's say if you have a team, okay, so if I have many people working on your project, okay, so let's say someone has been modifying your index.html. Okay, so if I click on index.html, and if I say this one, let's say I add well, doc type HTML. Okay, so someone's modified my code, okay, and they committed these changes. Okay, so now if we go to my remote repository, it says update index.html. So someone modified index.html. So what I can do here in my workspace, I can run git status one more time to change the status of my current working directory with the remote one. And it says your branch is up to date with origin main, nothing to commit, working tree clean. Okay. So git status doesn't know anything about the remote repository, so it doesn't compare it. But as a developer, it's actually your responsibility always to stay up to date with your team. So from time to time, you need to check your changes on the project. Okay. So the next logical thing is, if you would like to stay up to date with your team, is to pull changes from the remote repository to your working space. So for that, we are going to run command git pull. Okay, and it will pull the changes from the remote repository to the local one, and it will even tell you what are the difference between your previous workspace and the remote repository. And it says one file's been changed. We know that it was index.html, and there was one insertion. So someone added one line of code. Okay, so if we open our index.html, okay, if we open it in VS Code, for example, we can see that doc type HTML is present. Okay, previously we didn't have it because it's been modified by someone else. Okay, so but we pulled those changes from the remote repository, and now we have it. So and of course you can write your own code here, so you can finish it like this, and then you can once again commit changes to the remote repository, and someone will pull it for their space. So basically that's the quick overview of Git and GitHub, and also theory on version control systems. Thank you all for staying with me, and have a good rest of the day. And thank you, and bye bye.